Okay, good afternoon to all of you. In between, I will ask question and just what you have to do is that you have to give answers. Okay. Now here what happens that so I may not be able to see how many students have joined because I'm conducting it from the my device mobile. So in between, I will ask question. Okay. And just any one of you has to unmute yourself and you have to give answer. Is it fine? That's up.
Yes, sir.
Okay. No problem. Yeah. So we'll continue. Till now, what we have seen is the design procedure of joints, in which we have seen the quarter joint. Am I right? And we have gone thoroughly through that quarter joint, and we have seen how that various parts of the quarter joints are designed. Now, likewise, we are going to have one other joint also, and that is known as knuckle joint. It is very popular. If you compare knuckle joint and quarter joint, then knuckle joint is more popular than the quarter joint because knuckle joint is used nowadays everywhere. Why? Because it gives more degrees of freedom. Now, what are the degrees of freedom? You are knowing that if that particular mechanism allows us to have the relative motion between various links, then we are going to say it as a degree of freedom. Now, here, if you are going to see this knuckle joint and if you compare it with the quarter joint, then quarter joint does not have any relative motion between the various links which are connected with each other. That is nothing but socket, then spigot, and quarter. In that three components, we don't have any relative motion. Whereas, if you are going to see this knuckle joint, in this knuckle joint, we can have relative motion between the input, whatever may be, that fork or eye section, that link, and output link. Out of that, any one may become output. So we can have relative motion between that input link and output link, and hence it is more popular. So I will take one example where the knuckle joint is used in daily life. Same as we can say when we are going to join trolley to the tractor. At that time, whatever may be the joint which has provided between the tractor and trolley, that joint is a knuckle joint, because in that case, on the drawer pull of the trolley, we are going to have one eye section, okay, where one round section is there, and to the tractor side, we are going to have two, that is upper and lower section, that is called as fork, and we are going to insert pin between that, and that is going to become a knuckle joint, in which we are going to have that freedom that that is nothing but that fork and eye may have relative motion with each other, and that pin is going to allow it. So that Now, am I audible? Am I in meeting now?
Yes, sir. You are in meeting now.
Are you able to see screen?
No.
No. Okay, because in between this is happening. Okay. This is screen. Are you able to see screen?
Yes, sir.
Okay. So I was talking about this knuckle joint, and okay, this first slide. So I was talking about the various components which are there in the knuckle joint. Now see the components which that knuckle joint involves. First is called as fork end. That fork end is nothing but it is looking like a fork. Fork and two sides are there for the upper side and lower side. And in between that two, we are going to insert this eye section, where this eye section, when it is inserted in the fork, then the hole which is provided, that we are going to insert the pin, which is shown here by red color. That pin is inserted between that hole which is provided, and it will become a joint. And later on, to avoid the further, that is longitudinal motion of pin, we are going to lock it by means of lock pin and collar. That collar will not allow that pin to move up and down. Also, you can see here that collar is provided to the pin itself. So that pin will not move up and down and its motion is restricted. Now here you can clearly observe that the knuckle joint, that is we can have the two sections. One section is called as fork end section. Second we can call it as eye side. Okay. In between that eye and fork, we are going to see the rod which has elongated part of that eye and fork. That rod is transmitting the tensile force and it will be transmitted later on to the further side of the fork or eye, and it will be transmitted to the second part through the pin to fork or eye. Suppose here we are going to consider that the fork end is the end from where you want to transmit the tensile force. End is connected to the axle and end is connected to the trolley. So what we are going to consider is that that tensile force is provided through the rod to the fork end, and through that fork end it will be transmitted from the pin to it to the so we are going to insert the pin in between that fork and eye where the hole is provided to that fork as well as eye. Okay, and later on it will be transmitted to the rod which is connected to the eye, and from that rod it will be transmitted to the suppose trolley. Okay, so here these are the various parts of the knuckle joint which were to design. That is well as the process of various stress through which these four eye sections are going, and we are going to check the limit of that force as well as the stress which we get in the fork and eye section as well as in pin. And we are going to say that whether it is safe or not, various type of stresses. So as we are going to see this assembly of knuckle joint, there are 4, 5, 6 main parts. Okay, so this 4, 5, and 6, as I told, that are not more important. Okay, okay, that fourth part is no doubt is important, but fifth and sixth part, they are nothing but the collar and pin which is provided. Now truly we are not going to find the dimensions by considering the stress which are induced in that collar as well as in split pin. Okay, arbitrary both the dimensions of collar as well as pin, safety pin which we are going to insert in the collar. Okay, so mainly first part is rod. That is again it is a equivalent of fork. Okay, so that rod is important. Second, single eye section, that is modified rod for the assembly. That rod end is modified and it has become as a eye section. Okay, and double eye section, that is also fork, that two eyes are provided and two eyes are made as a fork to the one end of that rod. So it is integrated part of that rod only, that fork as well as single eye, and later on it has modified for the joint as we have seen in the previous slide, like this. Okay, so this fork end to the fork end, it is also called as double eye. That rod itself is modified in that way. Whereas if you are going to single eye, then also that rod has modified so that it has become single eye and they are connected with each other. And pin, which we are going to insert in that hole which has provided to double eye as well as single eye. Okay, and through that pin, we are going to transmit that tensile force for pulling of trolley. Where we have taken an example of tractor and trolley, so we'll consider it as a design of that knuckle joint for tractor and trolley. Okay, so we are going to provide the pin in between, and later on, to restrict the motion of that pin at one end by means of forging, that pin collar has been made to the pin at the one end. It is also called as head of that pin, and to the other end, we are going to provide one collar, and that collar, once you are going to insert that collar, then we are going to provide one safety pin also. It is also called as lock pin. Here you can clearly see in this diagram that green color collar has been shown, and in that green color collar we can see clearly that lock pin. That lock pin is inserted through the hole which has provided to the collar as well as the hole which has provided to the main pin. Okay, and hence that collar get locked and we can restrict the up and down motion of a true and fro motion of that pin. Okay, these are the major parts for which we are going to find the dimensions. Now you can see this assembly drawing. You might have drawn it in MD, machine drawing, for the assembly and detail section. Okay, so if we are going to see this drawing in detail, we'll start from the fork end side. So first part we can see here is the rod. Okay, then that rod has modified as per the, just a minute, if it is possible to have color pencil. Okay, now with the mobile I think it is not possible. Okay, so fork end has modified and it is further connected with the single eye section. Now here you can see the fork end. The radius which has provided to the fork end, it is that nomenclature which we are going to use as R for that. Okay. The next we are going to see dimensions of that fork end. So DO is the outer diameter of that fork end or double eye section. D1 is the diameter of pin head. Okay. Then D is the diameter of that which is inserted between double eye and single eye. Then here to the other side, you can see D2 is the thickness which has provided to the fork end. Okay, both eyes are of same thickness, so T2 is used. Okay, you can take your own time for getting this drawing. Okay, then T1 is the thickness which has provided to the single eye section. Okay, later on we decide as a diameter of the rod through which we are transmitting the tensile force. In further parts of this joint is that split pin, which we are going to use for the locking. Then collar, which again used for the locking purpose only. Okay. Now this drawing you can see as the front view as well as the top view of the same drawing. Now here D1, capital D1, is the diameter of the double I section and single I section 2, okay, which is elaborated part of the rod through which we are going to transmit the load. Here clearly it has been mentioned rod 1 and rod 2. You can see here rod 2, elements through which we are going to transmit the force. Okay. Okay. So let me ask one question. Have you understood what the drawing is and how that knuckle joint looks like? Anybody of you? Hello. To listen to me. Hello. That's why I told you that in between I will ask. Abhinay. Hello, Abhinay. Hello.
Yes, sir.
Are you able to listen me? And can you see the screen?
Yes, sir. I am able to listen you, sir.
Okay, okay. So everybody might be able to listen me. Now my question is open to all. Have you understood this joint? How it actually looks like and how the force is transmitted? Any one of you?
Yes, sir. Yes, sir. Yes, sir.
Okay. Praveen is saying that my voice is breaking. Praveen, are you able to listen me clearly now? Ubale,
Yes, sir. You are
no,
audible, sir.
I'm audible.
Yes, sir. You are audible.
So for the
Yes, sir.
okay, okay, I'm asking to Praveen Bhandare. Am I audible now? Okay, you please restart yourself and you can restart that device which is with you. So everybody is able to understand and they are listening me clearly. So you please check your connections. Okay, it is the question is open to all. Can you give me answer that what you have, whether you have understood what the drawing is and how that joint is looking like?
Yes, sir.
Hello? Okay.
Yes,
Now
yes.
can we go for the design of yeah. Can we go for the designing of components which are there in the joint?
Yes, sir.
Who is this Adesh Bandekar? Roll number 9. Bankar, not Bandekar. Roll number 9. Adesh, are you able to listen me? In true sense, I am not getting whether you are there or not. Aniket Bhosle, Amal Mali,
Yes, sir.
are you able to listen me?
Yes, sir.
Okay, have you understood how this joint looks like and what we have to actually do in case of designing of the joint?
Yes, sir.
Okay, then Omkar Pawar. Thank you, Amol. You can unmute yourself.
Yes, sir. Yes, sir.
Okay, have you understood how the drawing is looking like and what we have to design and what dimensions we have to find out?
Yes, sir.
Okay, we'll go further now. Now, nomenclature which we are going to use for this knuckle joint is, as we have seen in case of quarter joint, P, capital P is used for the tensile load or the force which you want to transmit, that is tensile force, which you want to transmit from one end to another end. Okay, that is capital P. Then capital D is the diameter of that rod through which we want to transmit the tensile load. Okay, and other thing is that capital D we are going to use for the both end rods, and we are not going to separate out that fork end side rod and single eye section side rod. So both for both the rods we are going to characterize as capital D. Then D1 is the enlarged diameter of that rod to the single eye section and to the double eye section too. Small I is the pin which we are going to insert that single eye and double eye section. Then D1 is the diameter of that pin head, which we are going to manufacture for the pin which is inserted. Okay. Then D0 or DO it is called as, rather than 0 we'll call it as a DO. DO is the outer diameter of that eye or fork. Okay. That collar which we can see in drawing. I'll show it once again. See, at the fork end side, you can see there are two circles on the fork. Okay, one is outer circle and one is the inner circle. So inner circle, we are going to provide space for the inserting pin, and outer one is the circle that in between that thickness is provided to the fork side or double eye side. Here also to the single eye section or eye, we are going to provide space to insert that pin. One is the thickness, inner side to outer side. We are going to provide the thickness at eye. So in this circle, we have small, okay, that is the outer eye. And what will be inner diameter? That inner diameter will be same as the diameter of pin. So it is not necessary to give separate dimensions for that inner side to the fork as well as to the eye section. So that inner hole size or hole diameter will be small d. That is the diameter of pin which we are going to insert. Then T1 is the thickness to provide to the end as well as, sorry, to the eye section, single eye section. Okay. And T2 with thickness of the fork end or double eye section of that individual eye. Okay. Then X as a distance of center of fork radius. Okay, where that distance we are going to mark for the last slide is radius. So of that fork for all eyes. Okay, so that is of the arc, that is the center point of that arc from the collar end of side, that we as X. That is also important because when we are going to design it, when we are going to manufacture it, that both the cases that X plays very important role. Okay, so that it is also it can change the load carrying capacity of this total joint. And last but not least, R is the from that point which we have decided right now to the circle where we are going to separate out that two eyes of fork. Next, step by step we'll go and we'll find the dimensions as well as the type of stresses which will get induced in that total joint. So first part which we are going to take for the design is the design of rod through which we are going to transmit the tensile force. Okay. Now here in this slide, you can see clearly how that tensile force is applied on that rod. And first of all, we'll consider that because of that application of tensile force, that rod start to elongate. Now what it means? Elongation means the stress will get exceed than its yield strength. That is the SYT which has played. Beyond that, if the stress is induced in that rod, that is nothing but because of the application of external force P which you want to transmit, then elongation may start, and we can consider that the failure may occur of that rod because of the elongation. Now, in case of ductile material, as already we have seen, though that rod is not going to have the two pieces, it has not converted into two pieces, but if the stress goes beyond the SYT, that is ultimate yield strength, then permanent deformation may occur in that rod, and that can be considered as a failure of that rod, though it is physically not converted into two parts. Okay, so when the elongation starts beyond the elastic limit, that also we can consider as a failure, and hence that we are going to consider as a limit for the induced stresses in that rod. So here the has been in which, or the area which has been shown, in which the tensile stresses will get generated. And this tensile stress, if it will get exceed than the allowable tensile stress, then we can say that the bar is going to get failed. Okay. So here, can we just formulate it in the mathematical formulae? If we are going to consider that P is the applied load and A is the cross-sectional area, capital A. Later on, we'll decide how to find the A. Then we can consider it as a force divided by area is nothing but the stress. And that formula here has been converted as load is equal to stress multiplied by area. Because stress is load divided by area. We are going to take area to the stress side. It will become multiplication. So we can calculate the limiting force which we can transmit through the rod. Okay. Then this can be written as a P is equal to area resisting the tension multiply by the allowable stress in that rod. Now this allowable stress value sigma T, that can be calculated from the SYT value which has given. That is nothing but the yield strength value of that material. That allowable tensile stress sigma T is given by SYT divided by factor of safety, as we have seen in case of quarter joint. In the quarter joint, already I have written the formula for that, and from that we are going to calculate sigma T. Once you have calculated this sigma T, that is allowable tensile stress or design tensile stress, then that value we can put here. Next, we have to choose the area. Now, area which we are going to consider is here, and that is circular one. Already we have decided the diameter of that rod as a capital D. Hence, the area will become pi by 4 capital D square. That's why formally for the force which is transmitted through this rod, that is again tensile force which is transmitted through this rod, will become P is equal to pi by 4 capital D square multiplied by sigma T. In this case, sigma T is the material property. Once you are going to choose the material, then from that material we can calculate value of sigma T considering Sue factor of safety. Then P, we can decide that force which has to be transmitted to the rod. Easily one can calculate diameter of this rod. So from this equation, diameter D of the rod can be found, and we can use it for as well as drawing of this knuckle joint. Getting now here only, if we are going to consider that diameter D, that is capital D, of rod, then the diameter of that enlarged part where we are going to start to manufacture the double eye as well as single eye, that is somewhat enlarged. Okay, again it has enlarged so that it will become easy to manufacture it. Otherwise the rod diameter D is capable to take the tensile load, so you can keep as it is, but to have the easy manufacturing we are going to enlarge it somewhat. We are going to enlarge it. You can see again drawing. See enlarge part. Example, nut type structure has been made. So that of that diameter. That is it. So that way of nomenclature has given as a D suffix 1. So that dimension can be calculated by empirical formulae. Here, if you want to consider the whatever the stress which will get generated in that enlarged section, that is also tensile stress, right? So from that, the value which we are going to get that will be definitely D, which already you have calculated. But as we want to have the enlarged part, that is, we are going to increase the dimension. So from design data book, we are going to take this empirical relationship, and we can find the diameter D1. That D1 is given as a 1.1 of that rod diameter. Okay, and from this we can find the D1 dimension. Okay, till now you can see that diameter of rod capital D we have find out. Then enlarged diameter D1 of that same rod we have find out. Okay. Up till now, do you have any question? You can write in comment box. Am I audible clearly?
Yes, sir.
Yes, sir. Aniket Bhosle is saying no, sir. No, sir means it is for the question which I have asked that you don't have any question.
Hello, sir. I am Aniket Bansode.
Okay. Are you able to understand me what I am talking about?
Yes, yes. Yes.
Uh, do you have any doubt?
No, sir.
No. Okay. Then Harshada Patil, do you have any doubt? You can write in comment box. Can we go further? Okay. We'll go to the next slide. This is the first step which we have seen for the knuckle joint. Now we are going to go for the second step. That is, we are going to decide the thickness of that single eye end, and that we have denoted as a T1, and thickness of double section that we have denoted as a T2. Now here we can use empirical relationship and we can find out T1 and T2 value. So T1
Sir, you are not audible.
Am I audible?
Yes, sir.
Yes, sir.
Okay.
Audible.
Can you see screen?
No, sir, no.
Okay. Now you can see. Can you
Yes,
see screen?
yes, yes.
Okay. Sorry for in between interruptions. Now we are going to see the second step, and I was talking about these empirical formulas where we are going to find out the thickness of the I end and fork end. That we have denoted thickness of I end side as a T1 and thickness of fork end side as a T2. Now here we can use empirical formulae from the design data book, and we can find out that thickness. T1, that is the thickness of I end side, is 1.25 of rod diameter, and T2 is the thickness of fork end side eyes, that is equal to 0.75 of D. And later on, once you find out this thickness, we can check the various type of stresses we may get induced in that single eye and double eye, whether that thickness is able to sustain that stresses or not, with the application of same load as a P, which we have considered as applied on that rod. Okay, same load will be transmitted to the fork as well as to the eye. So same load we have to consider for generating various type of stresses in that fork as well as an eye, single eye and double eye section. Now, third step that we are going to see is the deciding diameter of the pin. Now, in this case also, basically we are going to find out diameter of that pin, which has denoted by small d. And later on, by means of empirical formulae, we are going to find out the diameter of collar of or that extended part of that pin. Okay, so that diameter d1, small d1, which is denoted in the previous slide, that we are going to find out. Now here, when we are going to consider the pin, that pin basically will undergo to the shear, and that will be the major stress which will induce in the in this pin. No doubt that pin will undergo to the bending if it is capable to sustain the shear load. Definitely the crushing will occur of that pin, but major stress which will be induced in the pin is the shear one. Here you can see once this pin is inserted, then to the double eye section, the pin will be tried as a pulled by the double eye section, whereas single eye section, it will try to pull out his part. So it may undergo to the shear. Now here you can see same load is applied. Okay, that is P, which we have considered in case of a rod, tensile load. And where it has been written as a single P, that is nothing but the single eye side. And where it has been written as a P by 2, that is double eye section or fork section. And some load will be applied from the upper side, that will be as a P by 2. And from the lower eye, that force which will be applied on the pin to shear out it is P by 2. And the total P by 2, P by 2, that we are going to add and it will become P. So from both sides on pin, we are going to apply force equal to P. And we are trying to shear out that pin. As we have seen in case of quarter joint, it will happen same as the quarter which is inserted in between that socket and spigot. Here also, pin which we are going to insert in double eye and single eye section, that pin will get shear out. So how we are going to find the shear stress? Now same formula we are going to use, that force is equal to resisting area multiply by the shear stress. Now resisting area in shear we are going to consider, not in tension. Now here this slide, that wrong intimation or wrong description has been given as a tension. that area resisting to the tension, but this is the area which is resisting to the shear and multiplied by allowable shear stress. Now this can be written as P in mathematical formula. We can write it as a P, capital P, which we have used for the load, is equal to 2. Why this 2 is used? That again we have to understand. Because in this case, in case of pin, shear is not occurred at one place. This shear is occurred at two places. And these two places are nothing but the are separate out because of the double eye which single eye is trying to pull out. As same in case of quarter joint. So this two is used for double shearing of the pin. Is not occurred at one, is occurred at two places. That's why we use that two in the formula. So two times that area is resisting to the shear. That's why 2 multiply by pi by 4 small d square, that is the diameter of the pin which we are going to insert, and multiplied by sigma s, or it can be written as a tau, that is shear stress, allowable shear stress in pin. Now this allowable shear stress, as we have seen in previous that component which we have designed as a quarter joint, that allowable shear stress is calculated from the material property as a yield strength of that material property. If the yield strength is given by capital S suffix YT, that is SYT is the yield strength, then from this SYT we can calculate this value of allowable shear stress. How it is calculated? If you are remembering, then SYT divided by 2 is the shear ultimate shear stress. Okay, and this tau which we have calculated, that allowable, that tau is again divided by means of factor of safety. Then this sigma s or tau design can be calculated as this allowable tau, which we are going to calculate from SYT, this allowable tau divided by factor of safety. Okay, now it is in designer's hand that how much factor of safety we have to choose. While the solving problems, we are going to talk in details about this factor of safety. Already in first chapter we have seen that what the factor of safety is and what is the importance of that factor of safety. But while solving the problems, we are going to decide what value of factor of safety we can consider in such type of joints, where we are going to design or finding the dimensions of the joints, basically quarter joint as well as knuckle joint. Okay, so at that time we'll use this factor of safety and we'll choose some value of factor of safety. But here the sigma s or tau is calculated from the factor of safety, and factor of safety is used here. Okay, so we have we have calculated all the dimensions. Only thing is that we have not considered the other type of stresses which may get induced in this total joint. Only we have considered the major stresses. You can take first step, we'll repeat it. In first step, when we are going to find out the rod diameter, we have considered tensile stress. Then in second step, while we are going to calculate the thickness of eye end and fork end, at that time also we have used empirical formulae. Then in third step, where we are going to find out the diameter of the pin, that diameter of pin we have considered as a pin will undergo to the shear. There may be possibility. Here we can say whether that design is completed or not. So definitely not, because there may be possibility of generating other type of stresses in this knuckle joint. So we'll take other criteria based on which we have to decide the dimension of pin. And that criteria is nothing but if that pin is not failed by the shear, it may get bent. Most of the time you might have seen those who are having experience of connecting trolley to the tractor, they might have observed that though the pin is not going to get shear, it is, that is bending is occur in that pin. Again, that bending is tensile load, and that bending stress can be calculated from, as you see in case of quarter, that is area of y is equal to sigma by y is equal to E by R. Okay, from that we are going to find out, and here we are going to use this formula as the round section is used. That's why we are going to calculate that moment of inertia as a pi by 32 d cube, right? So that all formulas, that all things which from which we are going to calculate the bending stress value, that we have seen already. Okay, so here directly we can check this diameter of pin as a small d is equal to cube root of 32 divided by pi sigma b, where sigma b is nothing but the bending stress. Now this bending stress value, that is sigma b value, how it is calculated? Details of, anybody of you tell me b here. We have learned this thing. Bending means what? Whether we are having separate bending stress or it is a combination of tensile and compressive stress. It is a combination, right? So when we are going to consider this sigma b value, that sigma b value is nothing but the tensile stress value only, because at the upper end, at the upper side, that tension where it is generated, that will be the maximum tensile stress which will get generated when the pin will undergo to bending. That's why sigma b, that is nothing but the tensile stress value, allowable tensile stress value, is the tensile stress value that we have put here. Then small of 32 divided sigma multiplied by capital to Q by 4 plus T2 by 3. Okay, this bending is going to occur for this pin, and that will be calculated by considering the uniformly distributed load P has been applied on that pin. And when you are going to calculate the value of diameter d, small d of pin, then just we have to check whether this value which we are going to calculate by means of this formula is equal to or less than the value which we have calculated using previous formula. Now here, as we are going to use this P is equal to 2 multiplied by pi by 4 small d square into sigma s or tau. From this formula, we are going to calculate the value of small d. And if this small d value, the value which you are calculated by say, we are going to consider that pin is safe under bending stress also. Okay. We are going to calculate by means of this formula. If it is higher than the value which we have calculated with the previous formula, then definitely we have to choose the higher value of small d. Okay. So that's why this pin will become safe in shear as well as in bending. Now we'll move further. Before going to the next step and next values which we are going to analyze, next formulas which we are going to generate, let me ask that, have you understood these things, or do you have any question? Hello? Aftab, please unmute yourself.
Yes, sir.
Okay, have you understood all the things which we have discussed?
Yes, sir.
Okay, no problem. Nice. Please mute yourself. Nilesh Kadam. Kadam.
Yes, sir.
Okay. Have you understood all the things which or slides which you have discussed right now?
Yes, sir.
Okay. Can you tell me time? English.
2:30, sir. 2:30.
It's 2:30. Okay. So I think we have to stop here,
Yes, sir.
right?
Yes, sir.
Okay. Now we'll stop here and remaining part of this knuckle joint design that we'll see to the next lecture, that is tomorrow.
Okay, sir.
Okay.
Okay.
Okay. Thank you. Already